Welcome to solverfy.
Okay, so problem number 3 states to consider the free particle wave function of example 40.1, which is given by psi of x t is equal to a e to the I times k 1 x minus omega 1 t plus a e to the I k 2x minus omega 2 t. All right, so it says let k2 equal 3k1 equal 3k. Okay, so at t equals 0, the probability distribution function has its maximum at x equals 0. So part A wants to know what is the smallest positive value of x for which the probability distribution function has a maximum at time t equals 2 pi over omega, where omega is equal to h bar k squared over 2m. Okay, so now let's look at psi squared, the probability distribution function. So this is already given to you in the example, so I'm not going to work through the details of expanding this out, but it's given as 2 times the magnitude of a squared times 1 plus cosine of k2 minus k1 x minus omega 2 minus omega 1 t. All right, so now we can simplify this. So let's say we know k2 is equal to 3k1 is equal to 3k. So that means that omega 2 is equal to 9 omega 1, which is equal to 9 omega, because it's just omega is just related to k squared. Plug in 3k1, so that's 9. So it's a factor of 9. So we get psi xt squared is equal to 2 times a squared times 1 plus the cosine of 2kx minus 8 omega t. All right, so now for part A, where t is equal to 2 pi over omega, so I'll put a, so now at psi of x 2 pi over omega squared is equal to 2 times a squared times 1 plus cosine of 2kx minus 8 omega times 2 pi over omega, which is equal to 2 times a squared times 1 plus cosine of 2kx minus 16 pi. Okay, these omegas cancel. 8 times 2 is 16, left for the pi. All right, so now we want to find the value of x, for the smallest value of x for which this is a maximum at time t equals 2 pi over omega. So this is a maximum when, so psi squared is a maximum when this cosine term is equal to 1. You can see, because this cosine term is the only one that's going to, everything else can stay constant. This variable, this is the function here. So cosine is going to basically oscillate between minus 1 and 1. So it's at its maximum when this is at 1. So when cosine of 2kx minus 16 pi is equal to 1. So this happens at when the term 2kx minus 16 pi is equal to 0 or 2 pi, yada, yada, yada. So the lowest value of x is when it's equal to 0. So when 2kx is equal to 16 pi. So now solving for x, we get x. This is the smallest value of x for where psi is a maximum is going to be equal to 8 pi over k. All right, so now that's part A. Part B wants to know, where is part A? From the result in part A, what is the average speed with which the probability distribution is moving in the plus x direction? Compare your result to this given expression from example 40.1. All right, so part B. So the average velocity is given basically by, so velocity is distance divided by time. Right? So the distance is given by x is equal to 8 pi over k. And time is given by this 2 pi over omega. So the average velocity is going to be equal to 8 pi over k over 2 pi over omega, which is going to be equal to 4 omega over k. All right, so comparing this to, these cancel, omega over k, 8 over 2 is 4, so 4 omega over k. And comparing this to the expression given in the example and in the problem, the average is equal to omega 2 minus omega 1 over k2 minus k1. This is going to be given by 8 omega over 2k, which is equal to 4 omega over k. So they agree. That's okay.